Hi, everyone. Let's take a look at number 7 on page 386 for grade 12 calculus and vectors. Determine k given two vectors and the angle between them. 7a. Vector A equals to -1, 2, -3. Vector B equals to -6k, -1, and k. The angle between them, theta, is 90 degrees. Step number 1. If you write down the dot product, A dot B, so vector A dotted to vector B, by definition, equals to the magnitude of A times the magnitude of B cosine the angle between them. On the left-hand side, vector A is going to be -1, 2, -3. Vector B is going to be -6k, -1, and k. Now, on the right-hand side, if you think about this, the magnitude of vector A is going to be the sum of the squares, square root. So it's going to be -1 square plus 2 square plus -3 square. Now, likewise, if you look at the magnitude of vector B, that's going to be -6k square plus -1 square plus k square times the cosine of 90 degrees. Now, if you grab a calculator, or if you prefer doing mental math, cosine of 90 degrees is exactly 0. So this means the left-hand side equals to 0. And if you expand this, -1 times -6k plus 2 times -1 minus 3k, because you're adding -3 times k, equals to 0. So this implies 6k minus 2 minus 3k equals to 0. 3k equals 2. You bring -2 to the right, that's 2, which means the final answer for part A is going to be k equal to 2/3. So that's how you do part A. Let's keep going. 7b. Vector A equals to 1, 1. Vector B equals to 0k. And in this case, the angle between them is 45 degrees. So just like part A, you start with the dot product. Vector A dotted to vector B equals to the magnitude of vector A times the magnitude of vector B cosine the angle between them. On the left-hand side, 1, 1 dotted to 0k equals to the magnitude of A, which is 1 square plus 1 square square root, times the magnitude of B, which is going to be 0 square plus k square, cosine 45 degrees. Now, we're going to show you why this makes sense at the end with a diagram, which is what we're going to do double check in order to activate a dual mindset. On the left-hand side, 1 times 0 is going to be 0, plus 1 times k, that's going to be k. This equals to, again, 1 plus 1 is 2, so root 2, times, now be careful here, this is the square root of k squared, which is not k. It's the absolute value of k, which I'll come back to. Cosine of 45 degrees, you can grab a calculator, you can do it with the special triangles, that's 1/√2. So first of all, cross out 2 times 1/√2, which equals to 1. And again, on the right-hand side, this is the absolute value of k. By definition, the square root of k squared is the absolute value of k. On the left, you have 0 plus k, which is k. Now, the question is, what is the answer? If k equals to the absolute value of k, well, in general, you're thinking k must be greater or equal to 0. But realistically speaking, in this example, k must be positive. So there are infinite many solutions as long as k is greater than 0, where k is an element of real numbers. Now, let me explain this. This is where you really want to activate that dual mindset. Here we go. Draw a diagram. You want to really understand this. You don't want to just kind of do this and say, well, that's the answer. Let's keep going. Instead, you want to understand it. So think about 1, 1. This is vector A, 1, 1. Think about vector B. If you think about 0k in the most general format, it could be going down, it could be going up, because we don't know the value of k. But look at the answer. the reason why this could be the answer, this could be the answer, this could be the answer, is because there are infinite many cases as long as k is positive. So again, angle theta is going to be 45 degrees. K could be anything as long as it's positive. Notice we don't assume k is going to be 0 because that would give you a 0 vector. Then there's no angle, 45 degrees. So again, k is greater than 0 such that k is an element of real numbers. If you find this video meaningful, it's adding value to your math life, please comment, like, share, and subscribe. I hope this makes sense.